Greetings. Welcome to Drone Attacks on Industrial Wireless, a new front in cybersecurity in Lagoon K, with Jeff Melrose. Before we begin, a few brief notes. Stop by the business hall located at Bayside AB during the day for the welcome reception from 1730 to 1900 tonight. The Black Hat Arsenal is in the Palm Foyer on level 3. And join us for the Pony Awards in Mandalay Bay, BCD at 1830. Please put your cell phones on vibrate. Make it easier for the rest of us to ignore the ringing while your voicemail picks it up. For those of you that are still standing, find a seat before the fire marshal finds you and shuts us down, okay? And without further ado, here's Jeff.
All right. So we got a good volume? Okay. Excellent. As Alan was saying, my name is Jeff Melrose. I'm here to talk about drone attacks on industrial wireless. A little bit about me. I'm a principal technology specialist at Yokogawa, which is a leading industrial controls company. Might have a few customers in here, but we're not really typically considered an IT company. Before I worked for Yokogawa, though, I happened to work for a company called Lockheed Martin, and then before that, Raytheon, and I did military systems. One of the things that's interesting in this talk is how there's really kind of a crossover, if you will, of some of the problems that were in one sector, now we're seeing across the world in other sectors. 20 years experience in cybersecurity, published a few magazine articles, especially since I've been on the outside. Security speaker, I've given talks at AFPM, ARC Forum, DHS, security conferences such as SANS ICS Security Summit, and MIT IC3 Forum. Have a mathematics degrees, as well as I'm a CEH, CISSP, ISCP, GICSP. This is one of the few audiences I don't have to explain what those acronyms mean usually. And then also I'm a member of AFPM, ISA, and IEC Cybersecurity Task Force, and ISC Squared. It's a little bit of a shout out to AFPM, American Fuel Petrochemical Manufacturers. They are in large part kind of the thing that prompted this. Back in October of last year, I was talking around with a bunch of cybersecurity professionals in that industry consortium. And they said, yeah, we need to have something that talks to physical security people. These are people that secure plants, basically guards and gates and physical barriers and, serpentine wire, stuff like that. And they said, we have to have something like cyber that talks to them. And I said, well, yeah, why don't we talk about electromagnetic disruptions and electronic warfare? They said, great. And we had a Coast Guard guy there at the meeting that was talking about a lot of the cybersecurity stuff that the U.S. Coast Guard is doing. And it just came up that they had stories about drone incursions and stories about disruption. Specifically, the Coast Guard person was talking about disruption to navigation with GPS. So this talk began kind of organically within our community. I'm glad that there's a great deal of interest, certainly in the regular cybersecurity area. But this is something, like I said, that's come organically out of industrial. So the agenda today, we're going to talk about a motivational video. We're going to talk about, cyber physical electronic threats, what they are. Some electronic warfare overview, not too much, but at least so we're talking the same terms. And then some recent electronic jamming incidents and distance as a weapon for drones, how they come in, and then some drone threat scenarios. I'll actually be going back to some videos because I think, especially since we've got the big screens here, they'll show better. And then also I'll end with practical drone EW cyber defensive measures. Okay. We have volume. Okay, I'm sending volume. Great. The music's great on this. I love the music. Indeed. That's what you call the dramatic foreshadowing. So, the idea is that, get back into presentation mode here. When we talk about introduction to cyber-physical electronic threats, we talk about cyber and physical defined. NIST defines cyber-physical systems as smart systems that are co-engineered interface between the physical world and computer components. Example is, in my world, industrial control systems. Also, we've used terms out there called Internet of Things. In my field, it's more industrial Internet of Things, but you get the idea. So you don't worry about a chainsaw at 100 feet, but what about something that can get it rapidly within 1 foot? Some security assumptions that are just basic, especially in my industry, is an adversary needs to have close physical proximity. He has to get close to you, and we have this big fence around our property, 2 miles distant. We have a 2-mile perimeter. You can't get close. The drone reality is the drones allow an adversary to manipulate at long distances. Now hobby drones can travel up to 3 miles. Physical security can be minimized inside the plant boundary. Drones can tailgate workers as easily as people now. Many drones can navigate inside of buildings. So this is a big deal now because you've got some proximity. They can detect obstacles and they can go in confined spaces. So let's show an example of what kind of is going on. This is one of my early videos, but I wanted to make sure we kind of show this a little bit. So what we're seeing here is we're seeing actual, and that's a Noyatron, by the way. That's the actual quadcopter rotors there. This is a DJI Phantom 4. You see the video in the small screen that's actually coming off the drone. It's surveilling a temperature sensor, an industrial temperature sensor. So we'll actually see the readout there, So the idea is, can we get close? What do drones do? Can they actually work like that? Before I actually got into this, I was very surprised by how stable these platforms are. I don't know if a lot of you have played around with the little hobby ones that are like $50 or whatever that just kind of go all over the place and run into walls and stuff like that. The modern drones don't do that. So it's a little bit disconcerting that they can autonomously kind of handle a hover. So let's talk about where we're going here. Electronic warfare overview and why it's important. Electronic warfare, EW, is any action involving the use of the electromagnetic spectrum for directed energy to control the spectrum, attack an enemy, impede an adversary, interfere with an adversary's operations. Uses either electromagnetic spectrum or directed energy. The electromagnetic spectrum is the range of all possible frequencies, everything from gamma rays all the way down to very low frequencies, ELF. It includes visible light, okay? So yes, as you can say, it involves lasers. But we're not going to talk about lasers today. Maybe that'll be a future. Some basic electronic warfare terms. We have electronic attack. That's actual directed energy to cause a problem. Okay, like a laser, like a maser. Electronic protection, that's your Faraday cages. One of the things that has gone kind of to the forefront in certain areas in the world that Yokogawa has customers is we've been amping up what people do for isolation of equipment, specifically on, offshore as well as processing facilities. Just like this little cage here, we find that there's a lot more hostile electromagnetic environment in certain parts of the world. And then there's electronic support, which is much like my police band scanner or my radio frequency scanner. My radio frequency scanner can let me know that these things are going on. Okay, so I'm getting some transmission or a high power transmitter in my region, maybe that wasn't there yesterday. That's something that would be concerning. It's one of the recommendations that we tell plants now, much like they do a physical audit or a physical perimeter search, they should do an electromagnetic search, because spurious electronic signals can easily indicate something's going on, something's amiss as a tip-off. And then, of course, we talk about other EW systems like GPS that transmits 1.5, 1.2 gigahertz. And you can see a little graphic there of satellites moving into view and those types of things. Okay, so yes, did somebody say lasers? You know, directed energy could come from lasers, but it can also come from radio frequency. It can also come from microwave. Microwave would be a radar, okay? And then masers. Particle beam weapons, as well as sonic weapons. Some of examples I've had some exposure to is both the airborne laser system as well as the active denial system. Some people would say that these two worlds are really coinciding now. Electronic warfare, where we're actually trusting electronic spectrums, electromagnetic spectrums for ease of use, and then also cyber, because there's actually a computer answering. So, let's talk about real-world incidents that have happened in the past. In San Diego Harbor in 1999, a U.S. Navy radar test directed EMI, which was directed at a 900 megahertz. This is where a lot of the older generation industrial controls actually reside at this. Affected SCADA systems connected to the valves for the San Diego Water Authority and the San Diego Gas and Electric. A similar incident occurred in 2007 that led to GPS and other wireless services being significantly disrupted throughout San Diego. Emergency pagers stopped working, a harbor traffic management system guiding ships failed, as well as cell phones, ATMs. It was found that there's 2 Navy ships that were in the harbor. San Diego Harbor is a major U.S. Navy port, and they were doing a jamming training exercise. Oopsie. Newark Airport, 2013. FCC has fined a Reading man nearly $32,000 because it traced a problem to a Newark Liberty International Airport satellite-based tracking system. So what he'd done is he purchased online a system that enabled GPS signals not to be received. And the reason why is because he wanted to take a nap. He wanted to take a nap during the day because, he worked really hard in the morning. And then, during the day, it's like, hey, I could take a little nap. The problem was that his trucking company had installed a GPS tracker that knew when he decided to take a nap. So he decided, I'll afford that. I'll get a jammer so that they don't know where I'm at. And he decided to park next to an airport. Yeah. Now, what's interesting is you'll hear me use like little euphemisms about jammers, because I don't do jammers. And the reason why is because as part of the settlement with him, but also with the people that supplied him with said technology, they said the FCC wanted all of the U.S. customers of said technology. So, if you have one of those things, you might be getting, men in black showing up, knocking on your door. Den Helder, this is a little bit older, but it kind of shows you a little bit of something that actually impacts industrial controls. Gas pipeline control system located near a naval base. 36-inch valve was opening and closing. Those are big ones, by the way. 36 inches is huge. It's a D and L band radar, depending on which NATO spec you're doing, at 1.2 gigahertz to 1.4. And the system in the harbor, shock waves cause the rapid valve movements, cause a pipeline rupture. So these are real things that have happened in the past, but they've been associated either with somebody, driving a truck next to an airport or a military system. And then, I don't know if you guys are like any kind of rock fans, but yeah, radar love. Okay, so distance is a weapon for drones. And how do you like that picture, guys? I mean, I think it's very evocative. By the way, just so everybody knows, I did not cross the fence line boundary. This is only for example purposes. Okay, so EW hacking and distance. Physics students should be familiar with this equation. It's the radio propagation. Distance is a factor. The closer a transmitter can get to its target, the more effective he is, okay? It's called the inverse square law. At my AFPM talk, I'm talking to a lot of guys, physical security guys, so you don't talk about inverse square because they think you're talking about square dancing. Anyway, inverse square means, the closer I am to you, the more powerful. The further away, it's the square of the distance away. As you can see, that d to the second power. Hence, the possible use of something to actually bring it in closer to cause the little electromagnetic cone of silence on a transmitter or receiver in this case. So let's see here. Okay. Now, drones is a new EW threat. Drone logistics, this is something that I'll spend a little bit of time on here. Typically, a flight time is like 25 minutes, okay, right now. And that's mainly due to the energy density that you have with lithium-ion batteries now. By the way, environmentals changed that, as I found out. I was flying in the desert. You can have that changed. So anybody who has facilities in the desert, by the way, you don't have to worry as much. But temperate, sorry. Camera is the default payload because they want to actually do a lot of esports, or they want to do tracking of people, or take pictures, or do the whole Lion King. I can't remember the one where they circle around. They want to do that. Okay, no, Lion King's this, right? Never mind. Anyway. But it can carry small payloads, usually about 1 to 2 kilograms. It can carry little computers like Raspberry Pi. I've carried little transmitters as well. And then the range is around 1,000 yards according to this study. This study was done, the remote control project, it was social change by Oxford Research Group. This was out of British. It was a really good paper when it came out, and it's December of 2015. So it really kind of outlined all the commercial drones that are available and their distances. So it called, if you can read a little bit on the right there, it covered Parrot, it covered the DJI, it covered 3DR. It covered all of them, and it's got a good, overview of the distance that you can go and stuff like this. Most models can traverse, a range limit, though, in about a minute, because that's how fast they are. So a lot of times people say, well, it's only limited range. Well, actually, a drone can get there and back really quickly, kind of like do the physical security hokey pokey. However, just in 3 months, though, that list is now obsolete because the DJI 4, Phantom 4, came out. It has a 3-mile control limit, 24 to 28 minute flying time, 45 miles per hour speed limit. And then it has an optical target tracking capability. So that's going to be something that we're going to talk about in a little bit. These drone capabilities are evolving quickly. So people in my industry, especially in certain parts of the world, they're, these things are just showing up and they don't know quite how to deal with them. So anyway, as part of the background of how this all started is, so a funny thing happened in our net lab one day. I walk in and this is a sensor transmitter, and you can see the wireless antenna on there. The wireless antenna's got this thing on it. And I said, what's that? They said, it's a disruptor. I said, are you Klingon? What are you talking about? And he said, no, we use it. And I use it for what? And he took it off and he showed me. He says, a disruptor helps us test failure mode so that we don't have to go at long distances when we want to test when the radio transmitter fails. So immediately, and by the way, this is a meme. Immediately I go, oh really? Actually, that's my bird, Lily. Is she cute? Okay. So anyway, immediately I said, well, what about something simple like a disruptor on a, what you can do? You can just mess with people by putting something that'll disrupt the actual transmitter. Okay, so let's talk about that. Yeah, Lily got to ride one day. By the way, yeah, she just got to sit there. She didn't get to pilot. So it's lame, but the very first, I mean, literally the very first cyber physical drone hacking that we did, if you will, is where we just said, can you actually get this to hover? We got a drone. We decided, does it have stability to do this? And yes, indeed it did. And with me, sorry about that. With me, with about, 3-minute stick time, I was able to land it on there. It was surprisingly easy. And that's one of the things that's a little bit concerning is it doesn't take a whole lot for people to learn how to use these drones. It's really quite easy. The fine control movements and everything that were required were really, very straightforward. So, yeah, can be done. So, let's see what else we can do. So basically we said, well, what about like ideas where we can go from a physical security standpoint and we can go and have a person, and it's okay, by the way, this won't have any sound, by the way. This is a research assistant I have. She's out checking a field wireless sensor and then moving. And this is the drone. I'll move that cursor out of the way. This is the drone actively tracking her. Okay? And this is her dodging. I think she'd be running faster if she did. Now, this was an unarmed drone at the time. And then the Terminator gets her. No, I'm just kidding. I'm kidding. So when I show that to people, people go like, seriously, raise your hand if you think that's a Terminator moment. Come on, Rise of the Machines, come on. Okay. All right. So you can image track on moving targets. So that's something kind of concerning. Can a drone carry a transmitter physically close enough to replicate the radar valve incident? Given that the EW incidents mentioned previously, San Diego and Den Helder, the equivalent ASR, and I'm sorry, that's an acronym, that's actually Air Search Radar. EW system power proximity is 1.0 gigawatt. And like I said, I want to say 1.21 gigawatts. Anybody get that? Okay, I'm sorry. Okay, 1.21 gigawatts. Tom, how am I going to do that? The range effect. San Diego Harbor was impacted as defined distances, assuming Naval Base was the actual Naval Base San Diego was the actual origin. That's its name, by the way, Naval Base San Diego. Example: Yammers from Dinah. So obviously that's a euphemism. It rhymes with Yammers from Dinah. Unit states their effective radiated power is about 3 watts. So can 3 watts be effective getting close to? And then we did some calculations, and yes, a drone can get physically close enough. And the answer is the transmitter has to get within 8.66 meters. Boy, that sounds really deterministic, but around 9 meters, around 20-ish feet, to be able to cause an equivalent effective range of an EW system at range. Okay? 100 plus meters is problematic. That's something that's kind of involved to explain. So yes, you can have cheap radar love. So, can a drone maintain the electromagnetic distance autonomously on a fast-moving target? This is something that was basically a midterm experiment that we did that actually does a transmitter and then a vehicle and actual does that. So let me bring that up a little bit here. We're gonna pause this for a second because I want to explain what it is first. Okay, so this is the great hacking minivan of doom, And on the lower right-hand corner, we actually have a transmitter strength meter that's talking about from the drone transmitting how close, and we get basically a reading between 40 and 50 dB. So we're going to go ahead and show that. And you can actually see it follow, and there's going to be things that go and enter the frame. Notice that the drone is not distracted by this. That's, golly, I keep on, I'm sorry, there we go, okay. It's a little tooltip thing. And there's, this is a roadway, so it's just a little bit interesting that we have various things going on, but we had to pull over because cops got us. No, I'm just kidding. They didn't get us. But we were overtaken by bikers. But notice, the drone is not, he's locking on, he's following, we're doing this, we're still going on. Now we're gonna do a little bit of a speed test because I want to run over the biker. No, I didn't. I was very kind. I was very nice. And actually, I'll change lanes in a little bit here. But if you notice, the strength is staying. So I'm actually keeping within distance autonomously, not only from an image standpoint, but also from an electromagnetic standpoint. Oh yeah, there I changed lanes. Notice the, say again? Okay, so this is below 25 miles per hour in this case. In this particular test, we stayed below that. The reason why you hit about 25, 26 miles per hour, the drone has some trouble keeping up in the mode that we were operating it in. So the takeaway is that the speed limit of Terminators now is 25 miles per hour. Okay, now just, okay.
Is the Phantom the model of drone you were using?
Yes. Our experiments were with DJI Phantom 3 and Phantom 4. We've done some qualitative assessment with other drones. I can talk about that offline. So, I know that I can keep a drone autonomously within a certain distance. I know that I can keep electromagnetic distance. Now all that's left is to start talking about the mechanics of actually having something happen. One of the things that during our research that kind of happened but was very interesting because our customers asked us about this, the whole mouse jack thing, wireless keyboards and mice from 100 meters. Forbes, this is Forbes, February 23rd, 2016. Researchers have exploited a range of vulnerabilities in wireless keyboard and mice, taking control of them at up to 100 meters away, 300 feet, if you will. And then, a security startup, Bastille, so shout out to them, is talking about all these people, including Microsoft, bad. No, I'm just kidding. I love Microsoft, really. But with a drone relay, you can get within 100 meters pretty quickly, which is why we immediately told a lot of our customers, get wired keyboards. If you did not have the foresight to have wired keyboards and wired mice attached to your control systems for this exact reason. So can a drone keep a transmitter close? And yes, but there is actually a problem. There's a problem doing that, okay? And it's a little bit subtle, but I bet everybody in the audience might understand why. If the modern hobby drones use 2.4 gigahertz spectrum, as does Wi-Fi and 802.15.4, which is for industrial wireless. So any disruption needs to be away from the drone, or otherwise you've pretty much turned your drone into a brick if you're using a Yammer. A Yammer would be bad. So the idea is that this could easily crash, which was our original thought. We just put a payload really close. But in this case, we're going to tether it. We're going to fly. And it's really key that you start thinking about these types of interactions. Strangely enough, and this is really surprising to me, the drone control environment assumes a very benign electromagnetic environment. There's been some reports of people operating theirs in not so much in the West, but in other areas of the world, and all of a sudden having them fall out of the sky or immediately start going to home points. A lot of times the logic of these drones will immediately start, return to home if all of a sudden they lose connectivity with the control system, with the remote control. But it's definitely something that's interesting from a drone standpoint, that you would actually develop something that's an electromagnetic effect and actually fry yourself. So, can we keep a drone and keep a transmitter close autonomously on a stationary target? And the answer is yes. I'm going to try. By the way, the reason why I'm flipping back and forth is because for whatever reason in PowerPoint, I know, PowerPoint. But anyway, in PowerPoint, I get pixelization on some of my videos, so we're going to try this for once. If you notice what this is the actual tether from the quadcopter, from the drone, and then we're looking down on its camera, down at a transmitter on a pole. And, just to show you that it's not just like a static thing, we actually get like some pixelization. Okay, sorry. Dang Microsoft. So we actually are getting, looking down on it and seeing disruption to the actual sensor. Again, that was just a wireless sensor, and I know it's quick. We'll show it again here. Okay. So, we can do it on a stationary target, but for bonus, can we do it on a moving target? And that was the next field test and series of experiments that we did. So to explain what this is, that's a shopping basket right there. There's power source. This is a field wireless gateway. The best way to describe a field wireless gateway is you'll have like a field sensor that will be either set up as an I/O device or as a relay, and we're going to talk about that in a little bit. But the I/O device will transmit, say, my temperature is, my temperature is, my temperature is. And then the wireless gateway will in turn receive that and then move it into the IP network. So basically that's why we call it a gateway. It's moving in from just a radio frequency transmission into IP, and typically it has a little, either an RJ45 or an optical drop out the back of it that goes into a plant's process control network. Okay, so we put that on the mobile hacking minivan of doom, and an interesting observation is that this attack can also be simulating other types of electromagnetic uses within your other electromagnetic frequency uses within, that's being designed or utilized today. One of the things that came up was telematics and autonomous vehicles. So you could actually use this not only against 2.4 gigahertz, which is what was the default, you can also use it against 1.5 and 1.2 for GPS. So let's kind of show that a little bit. This is a good long one. Okay. So you'll actually see us come into a frame. This is the drone just sitting there. We've already turned it on for its tracking. I didn't realize that. I actually looked to make sure nobody was going to run me over. That was good. Isn't it odd, like having a camera watch you? Anyway. Okay. Come on, get going. Move already. Oh, another biker. So if you look over here, see the drone? See the drone shadow right there? That's the drone. That's one of the interesting things when you fly these things. At about 150 feet to 200 feet, you can still hear them. Now, one of the things for plants is noise protection. We'll talk about that in a second. But anyway, you can see the transmitter, the wireless gateway in the back. We've got our tethered transmitter that we're trying to get close. And one of the things is we had to kind of work it to where, the drone was actually closer this time and maintain distance. Another thing that's interesting, and we'll see it in a little bit, see how it's kind of fallen behind? This is where we were increasing speed. That's COP. No, that's not COP. Anyway, but one of the things too, there's a slight rise here. So the drones currently, this is current technology, do not adjust themselves autonomously. They only image follow, image track. And I think we stopped. Oh, yeah, that was me. And that was kind of disconcerting too, because right about then was when the tethered transmitter starts dragging along the pavement, sparks flying. No, it wasn't. It's a plastic encase, so we're cool. Okay, so I'd increased the height, kept following. It's the only thing I did, increase the height. Things are entering frame, things are leaving frame, and this thing's just very solid. Hey, nice Jeep. I think we're getting close to the end here. Yeah. Pull over. All right. So, yeah, one of the things that's interesting for industrial plants that gets to be difficult is that, and a lot of your warning systems now are based sonically. In other words, they detect the quadcopter's noise because there is rather a highly distinct whine that we heard in another video. But when you're, wow. Got really disoriented looking at that. So, but in plants, you'll always have ear protection. So a lot of people have been really worried about, it's like, well, how do we detect them if, like I said, our personnel is around high rotating equipment or something like that. They have ear protection and they'll never hear these. And I told them I got nothing because, outside of detecting the electromagnetic signals, that's pretty much about it. So the end result with this was that we only got about 2 to 10% packet loss off the gateway. Now, part of that was logistics of actually staying close to the dang wireless gateway. But the other thing is I'm not using Yammer from a certain country. I'm using just a regular tuned transmitter to do interference. I am severely limited by the jurisdictional and the laws of the areas that I do research. Although I am looking, so if anybody knows somewhere really close to North America where I can easily do this, besides Cuba, just kidding. Anyway, I'm very interested in a venue where we can do a little bit more on this. So let's talk about, now that we know that this can happen and this is a realistic attack and it's been demonstrated not only on stationary targets but moving targets, what can we do? Well, you can get in camo and you can shoot it. By the way, the FAA just came out and said you can't shoot drones. I don't know if you heard that. So if you're in North America, you can't shoot drones, no matter which window they're staring at. Sorry. So know your radio spectrums. First off is the unlicensed spectrum for 2.4 gigahertz is very, very busy right now. Very, very busy. There are a little bit of gaps, if you will. These are good gap areas that you can do for industrial wireless. Since Wi-Fi, 802.11, wireless, EMI gaps for Wi-Fi channels 1, 6, and 11. And therefore, in 802.15.4, which is industrial wireless, you can use channels 15, 25, 26. Note that, and 14 and 20 kind of, by the way, there's a little bit of more interference in those. And that's, by the way, the 802.15.4 enumeration. I want to be careful about that because certain vendors, they'll name their channels differently, which is really interesting. They don't name them like Disney Channel, but they number them differently. But there will be no gaps with a Bluetooth type interferer if it's actual powered enough. What's interesting is, at least domestically, it's really hard to get anything above a class 2. So it's really interesting that they kind of do that. So industrial wireless needs to go with a mesh network topology now. It's almost like a requirement, okay? Thank you, sir. The industrial mesh, actually, let's see, right on time. The mesh network topologies mean that you have multiple gateways. This is an example of several transmitters here going up and going into a wireless gateway network. But also what's interesting is that once you configure a wireless device, a wireless I/O, to go I/O and router is what it's called, at least with our systems, you're going to impact battery life. So you're not going to get 5 years out in the field like you would normally. It's going to be less than that. Industrial wireless networks versus EMI and distance. The EMI effects and RF reflection can work for you. It can do multipathing. So for instance, like tanks, vessels, reactors, cat crackers, whatever. The field wireless, use of field wireless repeaters. So this is a reflection example here. This is a repeater example where you've actually got, on your highest vessel, you've got repeaters that can repeat up from distance. This changed a little bit with the geometry. We're going to get into this a little bit. We'll talk about Fresnel zones. EMI spectrum survey should also be done. I know it's hard to schedule those and hard to find people that are competent to do it, but you need to do it, especially for a plant. And then also Yokogawa, has excellent guidance. This is a plug for them. We actually have a document out there that people can go to and kind of see. Certain overhead areas need to be secured. Right over here, this is an example of, and this was actually in USA Today article that came out. It's just, you can put a drone on a perch and leave it there. You only have 25 minutes for flight time, but once he's sitting there, they could sit there forever and start filming and really not impact the battery life so much. So long-term surveillance is actually possible with a perched drone. And that's what this picture shows. Also, because now you've got a 3D attack surface from a plant standpoint, your boundary can be bypassed. You actually have to start telling your physical security guys to check in odd places, check perches, but also check to see not only have you had any crashed drones, but also drones that may hang out in various areas. A drone can interfere with the Fresnel zones. Fences and doors and physical security, they should be secured. And it could actually land in a Fresnel zone and you'd have a persistent problem, not just something that would necessitate a flight time from a drone. And that's it. So if I have time for questions. Thank you.